Okay, I started the recording. We'll do this math problem. We started with new chapter, right? Everybody, chapter 14. And this is the math. This is the first math problem that we are doing. The homework, a little bit about the previous class. Homework number 6 is on Brightspace, right? Homework number 6. That's a new homework. Remember in last class, I gave the hints, right? Homework number 6. So which is due? When is due? When did I put? End of this week? Friday this week, right? Okay, by the way, I have an announcement for Friday. Friday I won't be here, but I will have a recorded lecture. Okay, so you're gonna have to watch it. I have a religious festival. Okay, so I can't be on the class. Is it okay? All right, so everybody watch the video lecture. And one thing I can do though, when you watch the video lecture during the class time, that be my suggestions during the class time. Watch it because you have the class time anyway, right? Engage to this class. Watch the video lecture. Don't come to the class, okay? Watch the video lecture, the class. Don't come to the class on Friday, okay? Just to be clear, okay? Friday, watch the video lecture, and you can ask me a question in OneNote, okay? Sorry, Microsoft Notes. Okay, so what I'm seeing notes. Teams, Microsoft Teams. You can ask me a question in Teams, okay? If you have any with the class. So the idea would be I'm gonna do another math problem, and if I'm gonna upload another homework, I'm gonna talk a little bit with the homework, okay, on that video. So the video is important, okay, Delina? Okay. All right. So now the today's agenda. I don't want to take too much of time. So what we'll be doing, we're gonna apply. I already started with the theory in last class, right? So we're gonna apply the principle. That's the thing. First thing I would like to write principle before even I jump into the math of work and energy, because that's the equation that we'll be using. Okay, what is the equation for principle of work and energy? Say like as of this example, we are seeing a block is moving from position 1 to position 2, right? It's a dynamics class, everything is moving, right? So if the block is moving position 1 to position 2, say like initial position 1 has a kinetic energy which is T1. By the way, T is referring by kinetic energy, okay, is equal to T2. Here you have the summation of other form of energy like potential energy, spring energy, or whatnot, everything, summation would be U12. Then you can write this equation, and this is called principle of work and energy, okay? So we're going to use this equation. So try to understand this equation first, okay? So then let's start with this problem and see if we can connect this equation with this problem, okay? Or how to solve this problem. So in this problem itself, what you're seeing here, a block is hanging by a wire and a spring system in a slope. Okay, so the block itself has a weight of 10 kg. So block itself has a weight of 10 kg. By the way, all the material I think I already uploaded in Brightspace. If not, I'll check it again today. So when the block is at 0.6 meter, so this S value, they said like this is 0.6 meter, okay? So this is your position 1, this is your S1. Then the spring is not stretched or compressed. So as if like the block started at a point at point 1 where the spring is just barely attached with that block. You understand that? Lina? So the block is barely attached, okay, as if like it's just barely attached, okay. So you have this initial location is s equal to 0.06 meter and the block is 10 kg. Then what happened? Then there is the external load 100 Newton. So that's the load, external load 100 Newton applied here on the block. What will happen then? The block will obviously go down on the slope and then it will have a new position. The question is asking what would be its position. Okay, I'm gonna go back to that. So it says that force 100 Newton external force moved the block with a speed of 5 meter per second and down to a smooth plane. When it says a smooth plane, immediately you know there is no friction, right? And the question is asking find the distance when the block stops. Obviously the block is going to stop, right? because it is a spring attached with it. And no matter how hard you're gonna push it, it's gonna stop, right? The spring is attached to it. You see that, right? So you gotta find the final position as. That's what you're gonna do. Can you do that by using that equation? Everybody comprehend, understand the problem? Yeah, the block is on the slope, right? It is pulled up, even though it's attached by a spring. It is pulled down, I say. It is pulled down by a force 100 Newton. Okay, with a speed of 5 meters per second. The initial position is S1, you can say 0.6 meter. They're asking what is the final position S2. That's all the info given. And I'm saying using this equation. Now here, these T's, I say, those are the kinetic energies, right? You remember the kinetic energies equation, which is what? Half of mv squared. You remember that? Okay. And let's focus on the T term first. You have this position 1, position 2. At position 1, what is the velocity? 5 meters per second. So the block mass is given as well, which is what, right? 10 kg. So can you find the position 1 to 1, Joe? Which is half of mv squared. Okay. What about the T at position 2? Is there any speed at position 2 for the block? Is the block any further move? No, it doesn't. The block stops, right, at position 2. So what do you think that T2 would be? Half of mv squared. If v is 0, then T2 would be what? 0, right? So now you have this T1 and T2. You have to take care of this U thing, right? What are the U's? Like the U could be any form of energy, like because of the potential. Because of the position of the block on the slope, there is a potential energy on the block, right? Like you remember, what is the equation for potential energy? The kinetic is half of mv squared, right? What is the potential energy equation? Is it like something has to do with the G, gravity, right? Is it like mgh? Remember that? mgh, everybody remember that? Alex, remember, right? mgh, the potential energy, kinetic energy. You might learn it in the fundamental physics, right? mgh. I don't know. So mgh is alright. So mgh, mg is the mass, g is the gravity, h is usually referred by the height, right? So when the block is moving from position 1 to position 2, we'll have some vertical distance traveled by the block. So that's the vertical distance is important, not by the S1 to S2. You see, Arlene, what I'm saying? S1, so the block is moving in this slope, right? When the block is moving in a slope, the distance that it travels, Joe, you understand, right? The block is moving from the distance it travels from here to here. It's on the slope. It's not the vertical distance, right? What is the vertical distance? Vertical distance is from this point to this point, right? This is the vertical distance that the block is moving. So can you find the vertical distance from this? Should be right, but if you know the theta. Do you know the theta? Theta of the inclined plane is 30. So now you are starting to getting into what is this U. One of the U already figured it out, right? Which is the potential energy. Okay? Alright. Is there any other U? There are two more. There is this spring. The spring does have, remember in last class, that was by exercise. What is the spring energy? The spring force we know is K. Spring force we know is Kx. K is the spring constant, X is the displacement of the spring. Everyone knows this, right? By heart, Kx. But the spring force now we're talking about the spring energy. In last class we did explore that. Remember, it is something to do, it's similar to kinetic energy. Half of, did you remember the spring energy? Half of Kx squared. Did you remember? Yeah, so K is what? Like the spring constant, X is the displacement, right, Logan? So, okay, so now you have this, I'm talking about U now, right, Joe? So, first U is the what? Like the potential energy, right? Remember the altitude I was explaining? What is the second U? I was talking about the spring, right? The spring is half of Kx squared, so that would be the second one. You understand, Joe? Okay, what other force, Alicia? Is there any other force involved other than this kinetic potential and spring?
On the block?
On the block?
Normal.
Yeah, there is a normal as well, but if I'm gonna consider this thing, if I'm gonna consider this thing like the block is moving by external force of 100 Newton, does it have any effect with that 100 Newton? The 100 Newton force pulling that block down, right? So when the block goes down along this line, what happened here? When the block goes down along this line, the force multiplied that distance you have to consider. Does it make sense? So that's the work done. So how many forces? First, I started with three forces. You are absolutely right about the U, right? But first, we started with the T1 and T2. Everyone understand that, right? And this U is measure of U, and in other words, right? There's three components, right? What are those? The spin, the external force F, and the gravity, the potential energy. Okay, that's what this thing is called. Work and energy, right? Joe, you understand? Yes, the balance is work and energy. Now everyone understand the whole problem? Should I start with the formal approach? Dealing with the problem, okay? So this problem would be dealing with work done. This is, I would like to still keep it in the side note. So work done by three different forces. What are them? By the external force F, by the spring, and by the weight. Okay, let's start with the external force. So the external force F, which is 100 Newton, and the work done UF can be written as 100 multiplied S2 minus S1. Now you already know what is S2 and S1, right? So if we're gonna draw the sketch again, and the block is looks like the black color block. So like this is your S1. The block come into this position. Say like this is your S2, right? So those are your location, and then this spring, you can now draw this arbitrary spring this way, right? Bottom line is it's like a sketch for what we're seeing here, right? So you have these two blocks, right? Drawn here, S1 and S2, those are the location. So now that you understand this UF because of the external force F, so this is the external force F acting on this block, right? Okay, and then this distance, let's start with the spring first. So the spring force US, the subscript S for spring, F for external force, if you understand, can be written as half of K S2 minus S1. That's the displacement, and you got to put a negative because you're doing S2 minus S1. That's from the equation. Okay. Aline, you understand S2 minus S1 is the distance traveled by the block, right? And the spring is attached with it, so that much extension happened on the spring, right? Okay. Till you know you got it? Why did I have S2 minus S1? Why? Because the spring is attached to the block, right? If the block travel S2 and initially it was S1, so the distance that the block travel is S2 minus S1. Does it make sense? All right. Good. All right, so this part is done, and then after the spring, finally the weight. The weight is a little tricky. You gotta get it involved with the theta, the slope. What is this theta? 30 degrees. So let's do that. Weight. U, I'm gonna stick with the symbol U, weight, which would be mg, so mg, okay, multiplied S2 minus S1 sine 30. Why sine 30? You guys remember from Pythagorean, right? This is theta, and this is what? This is the h, right? You guys remember from Pythagorean? And say like this is s, or in other words, say like this is S2 minus S1, right? So can you write it 10? So can you write it, sorry, sine theta equal H S2 minus S1. Can you write it, Arlene? Arlene, you remember this trigonometric relationship? Sine theta equal to height divided by hypotenuse. Did you got it? So that's your clue to write this UW. Okay, sine 30. All right. So now that this thing is done, you guys are actually ready for the math. Now we're gonna. These are all background so far. What I did. We're gonna start with the formal approach, means the engineering approach. So what are the givens? I did talk about it. Remember, the velocity is 5 meters per second. That's given. The initial position S1 is 0.6 meter given. The mass of the block is 10 kg given. And the external force is 100 Newton. Now you don't have to write it next to one another like the way I'm doing, right? Do you know what you're gonna do? You wanna write it one after another, right? I'm just doing it because you can see the whole thing, okay, in one slide. And then the spring constant also given. There is this spring constant K. What is the spring constant value given, guys? Did you notice? It's 200 Newton per meter. So that's the spring constant. I know some students still struggle with spring constant. Let me write that thing what it is. So it is called spring constant. Okay, so what you are trying to find? This is already here, but we're going to do it again. The distance S2. Right? So that's what you're trying to find. And now I'm going to just simply do one final thing, and then I'll let you guys finish it by yourself, right? One second. What is happening here? I'd like to make it a full screen. Okay. So I'm going to do the one final thing, means I'm going to write the solution, obviously. The equation. So that work and energy so I have this T2 plus summation of U1 to 2. That's the position 1 to 2. Tell me, you're taking notes? Anybody want to give a pencil to? Okay. T1. All right. All right. So T1, T2. Okay. So everybody already know, right? What is this T1? Oh, by the way, I'm sorry. This is T1. And this is T2. Let me rewrite it again. So this is T1, this is T2. So half of mv square. Did you know I'm putting this record on lecture on record, so you have the opportunity to explore it again when we're going to go home. All right. So then the three form of energy, right? This capital U1 to 2, and that one I don't know. Maybe I'm gonna put it inside a big bracket, I guess. So you can identify clearly. So 100 S2 minus S1. So I'm skipping the units. I'm gonna keep every unit in base unit, right? So that is that. Then plus half of K S2 minus S1. We do know what is S1, S2 and everything, right, already. And then finally we have this 10 multiplied 9.81. Now you remember the base unit must needs to be in kg and meter per second square. Otherwise, Aline, you're taking notes, right? There's so many things happening here. So so then you have this S2 minus S1, right? And the whole thing is multiplied by sine 30. Okay, we've seen that already. You can actually put sine theta as well. But since I started plugging some values, so I'm going to do that with sine 30. Now, what would be my T2 value? It's 0. And I mean, if I'm going to write it in other words, like with the V2, and this is my say like V is already given. So I know this is 0 because you can write it this way. The block stop at position 2. Joe, you understand? All right. So that's it. So perfect. So now it's time for you to just simply plug the values and solve the value of S2. Okay, that's pretty much it. Now this is a complex, I'd say complex algebraic problem. Okay, So you got to do a little bit of math here. It's a little bit of math. This is a quadratic equation. You guys remember the solution for a quadratic equation? Like if you have ax squared plus bx plus c equal to 0, where the x would be minus b plus minus square root of b squared minus 4ac divided by 2a. You remember that? That's a quadratic equation solution. Don't worry, I'm gonna write everything on the notes and everything, but it's coming just to give you a flashing thing what is coming. Okay, so let's just focus on the values. So you will have always you'll have obviously a half is like 0.5, block is 10, and then 5 meters square, and the whole thing is in joule if you are using the base unit, right? Everyone understand? All right. All right, whole thing is in joule, and then you have this 100. Okay, then you have this 100 as 2 minus 0.6. I'll just simply plug all the values. Okay, so then half of that's the k value is what, 200, right? And then s2 minus s1 is 0.6 square, and then you have 98.1. If you multiply 10 with this 9.81, and then sine 30 then s2 minus 0.6. The whole thing is equal to 0. And from there, what did you see is missing here? S2. And other than that, all the values are computed. So you got to grab a calculator now and see if you can come up with a solution for this. And if you remember what you're trying to do here, solving a quadratic equation. What is the quadratic equation? I'm going to put it as a side note. So the quadratic equation is ax squared plus bx plus c equal to 0. And then the x value could have two values, right? You have say like x1 and x2 minus b plus square root of b squared minus 4ac divided by 2a. This 2 looks a little weird. Let me rewrite it. So 2a minus b minus square root of b squared minus 4ac divided by 2a. Okay, so before even you start solving this equation a, b, and c, you got to need those two values, right? And okay, so before you got into that point, what are you going to do? You're going to come up with the value of a, b, and c. All right, how can you do that? I mean, this big math that you're seeing, you got to do it, right? So I mean, let me do some of it for you. Let's see if it can help you. So the first one would be 125 plus. So you have this 125 plus this 100 s2 minus 0.6 minus 100 s2 0.6 square plus 49.05. I'm now doing the math. S2 minus 0.6. Okay, and then what? Then you can do one thing. You can use this equation. Remember, a minus b square equal what? A square minus 2ab plus b square. You can use that equation, Or you can just simply think this whole thing here is x. Can you think that? I want everybody to replace this as x. Can you do that? So if you're going to replace it with x, then you're going to have something similar to like that. 125. And you see this 149 both as x. I mean, let me write it anyway. So x minus 100 x squared plus 49.05 x. Now solve this. Now obviously this will going to become minus 100 x squared 149.05 x plus 125 equal to 0. Yes. You have a different value?
Where do you get the negative 100 from?
I thought I have a negative here.
In the first line, you have plus 1/2 times 200.
Oh, yeah, there is a mistake I did. It should be negative. There is the plus from this equation itself, but on the equation itself, remember, there is a negative.
Okay.
All right, so there is a negative. Let me do this thing here, plus minus the whole thing. Okay, so there is a negative because of that. You may want to write the negative the same way here, plus minus half, right? Got it? All right, so now you know what is the value of a here. Is it minus 100? You remember what you're doing? You're comparing this. You understand? So what is the value of v? Logan? 149.05. Brad, what is the value of c? Is it 125?
Yeah.
Okay, now that you have these three values, can you find the value of x1 and x2? I want everybody to do that. So you want to do this equation. Square root of b square minus 4ac 2a. Delino, do the math. Grab your calculator and find the values for x1 and x2. Okay, find the values. Why do I bother in finding the value of the x, right? You know that, right? Because once you find the value of the x is actually s2 minus 0.6, right? So in other words, you did assume that, so s2, so x, so let me put it this way here on the side, where x equal s2 minus 0.6. You want to take this note. I know some students get struggle, get confused or whatever. Whatever state you are, you should be, if you understand this. You understand it? You know what is happening here? So your goal is to find the value of x1 and x2. By the way, 1 and 2, the subscript that I use can be used here for x, right? It's the same thing. I'm waiting for you guys. Whenever you have some values, let me know. So you definitely want to plug these values like this way. So minus 149.05 plus 149.05 square minus 4 multiplied a. What is a? Minus 100. What is c? 125. right? And then 2 multiplied a, what is a? Minus 100, right? Did you got it? What is the math? What is the value got?
For x1, I got a negative 0.73.
I have negative 0.598. Check. You want to check the math?
Yeah, I'll check.
Okay, so minus 149.05 minus.
Oh, I didn't square it. That's why.
Okay. So for x2, Brody, what's the value for x2 you got? You got it? Does you know now?
Yeah.
Brody, what's the value for x2 you got?
I'm still working on.
Anybody got it? Alyssa, you got it? Brett?
Working on it. I got 2.089.
Perfect. All right. Now, can you find the value of S2? Let's see. That's the task. Find the value of S2. How? Remember, we assume x equal to S2 minus 0.6, right? So I can tell you one thing though. Out of these two results, only one is true, one is false. How do you know which one is false? It can be negative, right? It can be less than 0.6, right? So you want to try both of them and see which one is correct. So now, obviously, you have this S2 equal, if you're not trying to find that. So S2 minus 0.6, which can be, say like, assume that is X1, okay? Equal minus 0.598. So maybe I want to write this thing this way. So say like x1, you're trying to find the you're trying to apply the value of x1. Let me do it a little bit differently. So case one. Let me do it formally. Say like x1 value you found minus 0.598. Now you know x1 can be written as s2 minus 0.6. Okay. And then if you're going to do the math with this one, it would be almost zero, right? 0.986 and so S2 value would be what, right? S2 value would be like 0.6 plus almost 0.6 minus almost 0.598. So is this a feasible result? No. So actually 0.002. Actually it's zero, almost zero. The value of zero. It's not a feasible result. Okay, so the value of S2, the location would be in case 2. In case 2, you know you have x2 equal 2.089, which is S2 minus 0.6, right? So what you want to do, you wanna rewrite this, right, in terms of S2 minus 0.6 equal 2.089, and then you want to rearrange this. So S2 will become what? 2.089 plus 0.6, so which would be 2.689 meter, right? This is why I'd like to put the unit here. See, even the simplest form of math can be a little bit complex when the math or algebra is so difficult. Okay, this one is not too difficult, but still it does have some form of work, right? The quadratic equation solution that you're gonna do, and that's it. That's it for me. And on Friday class, okay, the video lecture that I did, I'm gonna remind you by sending me email and everything, okay, formally. But the video lecture that I was saying, you have a math problem solved. Possibly, if I can upload a homework, I'm gonna talk a little bit about that as well. I mean, that homework won't be due until next week because there is one homework we're still doing right on Fridays too. So there won't be like too much of confusion. But since now we have one problem done on this chapter, you guys are technically ready for this chapter homework, okay? Okay? It's good. There's no more question. I'll see you next week Monday. But watch the video lecture on Friday, okay?